And I got that. And I will start as well with introducing Joel, whose seminar talk today is If the Future Past Teaches, What Does the Present Learn? Quite an intriguing title, I must say. And also links back to a book title that was, well, a book that was published during the summer called If the Past Teaches, What Does the Future Learn? That was generated from a series of workshops that a bunch of us had at CSINC in Maryland over the last few years, a series of workshops in which Joel took part. So this discourse, this idea and discussing of how archaeology generates insights on present issues is also, of course, one of the key elements or key arguments for the Integrated History and Future of People on Earth research network. I prefer to call it a research network. We can have a discussion about that, in which obviously this seminar series is part. So it's very key to the IHOPE effort. And of course, Joel has been a member of the scientific steering committee of IHOPE for quite some time. So Joel is a lecturer at the Department of Anthropology at the University of North Carolina at Greensboro in the States. And he's, for me, he's mainly a Mayanist. I see in his self-presentation doesn't really present himself as a Mayanist, but I very much think of Joel as a Mayanist with a particular interest in climate studies. And of course, Joel has published a series of key texts on the relationship between changing climate and cultural impacts, particularly in the Mesoamerican area. What probably the most well-known title is The Years Without Summer, about the AD 536 event, about 20 years ago was that published. But in general, he's working with the different cultures that are affected by the movements of the different features of the atmospheric circulation in the North Atlantic, and particularly the highs, the Bermuda High and the Azores High, and particularly then on the Maya, but also this atmospheric circulation has relevance for, not least for the Roman Empire. But so in this talk, he will draw on cycles of stability disrupted by instability in the first millennium CE to reflect on the period since World War II that we often now call the Great Acceleration, and focus then on what are the insights that archaeology generates from his perspective. Please, thanks, Joel, for coming here, and we look forward to your talk. Please go ahead. Can you open your PowerPoint, or should I open yours? I think it's better if you do it.
Yeah, let me see if it works. Annalie and I have already practiced this, so
okay.
We probably.
Did you succeed then?
Oh my God, how about that?
Indeed, yeah.
So the book that Christian mentioned about the if the past teaches, those sorts of things always kind of raise questions in my mind about what, about this business of what's the relationship between the present and the future and the past, and I was sort of trying for a play on words there that somehow resembles space-time, but is more social science friendly, I guess you would say. The future past is kind of like more of an anthropic perspective on it. Einstein's time-space model doesn't really give us much room for change and everything. As a matter of fact, most of the interpretations that I see of Einstein's model is that it's that the present is an illusion and the future and past are set in stone, and so things don't really change. And I think that this is probably mainly an accommodation to dealing with huge billions of years concepts, and an accommodation for needing to deal with that in terms of a mathematical model. But John Wheeler's ideas about the participatory anthropic universe is probably more the domain of time that we're interested in. And it's especially in a time where, according to some analyses, there's 3.5 billion people, if things continue as they are, will be under threat for their existence in the next 50 years or so. And I've been spending quite a bit of time working with some people that call themselves biophysical economists, and these they're of the same vein that Bob Costanza is, that they want to change economics so that it incorporates ecosystem services and those numerous other aspects of the life of the Earth system. And one of the things that I have encountered with them is that the future is not only presumably very flexible, but we have a certain amount of insights into what's going to happen in the future, and so we sort of need to exploit that. And actually, I had a recent experience where I asked a history graduate student if he would try to give us some worldwide perspective on sacred kings, and including the Maya-Lowlands, which is the point of the paper, or the Mesoamerica, which is the point of the paper. But I had this experience after reading his paper, like he's never looked at Maya-Lowlands archaeology and history, and so he's read all of the latest and greatest stuff on sacred kings in the Maya-Lowlands, and as a consequence, he's driving this shiny new concept that is based on all of the latest stuff and everything, and I had this decided feeling when I read his chapter that this guy is, he's the present, and I am the past, because I'm dragging about 3 decades worth of chains of sort of Dickensian chains of different kinds of models that are not so shiny anymore and stuff like that. And I guess I should just say that I'm glad to see that he's abruptly made me aware of this at the moment that I'm trying to think through what is the difference between the present and the future. And so I thought it just give us a little view of what the different, what the implications of the near future are. It's the near future that we really have some fairly good sense of. And as a matter of fact, this paper that I did with John Day and another person, and really many of these biophysical economists, is looking into what kind of impacts global warming is already having. And the paper was set in a volume of coastal cities and stuff, and one of the things that came out of it is that as we all know, there's a certain amount of sea level is baked into the cake already, and that the There are places, that are not even tropical, like New York City, that are in danger from high floods, and there are places like Mumbai that have daily floods, seawater running in the streets without the benefit of any kind of special conditions. And there's a whole list of other things that we traverse in this paper, but no, I think that the sea level one is the one that is most awakening. That it's really a huge problem in the near future, happening right now, especially in the Far East and Near East, where most of the megacities are in the tropics, which are, for one thing, having a whole bunch of one species, as Vern is happy to point out, gathered together in one place is just not tropical. It's adverse to tropical ecology, and these cities are, many of them are at sea level, and their landscapes are sinking because of the drawing out of water underneath of those cities, and so there's just billions of people that are at risk in these mega cities, that many of which are the most the largest and most heavily subject to these rising sea levels. Something else that's going on in the biophysical economics world is that petroleum, these people have been studying what's going on with petroleum, which they regard as being the glue that holds the modern economic system together, and without it, megacities will probably not be possible anymore. And the estimates that are available on how much petroleum there is available in the world are just not reliable. They think that probably that accessible, affordable petroleum will no longer be available to you, in a kind of a time frame that's more like 30 to 50 years rather than to the end of the 21st century. So there's just a lot of stuff that we need to have a vocabulary, which Murphy and Crumley helped by giving us a term durability, and probably we need a sense of time and a lot of other things that can be boosted by thinking about what's going to happen in the near future and the far future, and so on. One of the most startling things, I think, is the business about the human eco-niche, and how in the Holocene, the variability of the climate is spanned a few degrees centigrade, not a great deal, six 2 or 3 degrees centigrade, something like that. So humans in general, and certainly the crops that humans depend on and all of that, are adapted to this kind of narrow temperature range, global average temperature range. And then if you run simulations like like this person Xu did with the help of many other people, you come up with some numbers indicate that in the next 50 years, the human eco-niche is going to basically migrate out of the range that humans, Holocene humans, evolved in, and there are going to be winners and losers in that. You hear a lot about losers and winners, and basically the Canada and the Soviet and Russia are going to be the winners, and the losers, basically the rest of the world, which are the red parts in this map here. on top of that, less predictable, but nevertheless more frightening, is there are things that could happen. Some of which has been on the books for decades that I know of, which is a threat from methane suddenly being released into the atmosphere. And methane is a very important greenhouse gas, and certainly could disturb what's going on with the world. And they ran this simulation on something United Nations SP3 scenario. So I tried to figure out a little bit about what it's about. But anyway, it's one of the more pessimistic scenarios of what's going to happen, probably involving business as usual and things like that. And they're seeing 3.5 billion people exposed to problems generated by this migration of the human eco niche by 2070. So that's a little flavoring of the future. Some of it somewhat predictable, some of it not very predictable. And then looking at the past, where we have records of durability, we have I've been interested recently in how appropriate so many of the first millennium AD civilizations are in terms of what's going on that is facing our current world civilization. And this is basically looking at the idea that not only is the present world economic system a hegemony with something apparently as feeble as the United Nations, but nevertheless probably the only way out of the mess that we're in. But you have what I've been thinking of as mouse models in terms of civilizations in the first millennium AD, or CE, which is small hegemonies. And we have one in the Maya lowlands. The Khan dynasty is closest thing that they ever had to an empire in the Maya lowlands. And of course the Romans and the beginnings of the Southeast Asian civilizations, all of those things are going on in this period. And there's a lot of other things that recommend the first millennium AD. It's where history and archaeology overlap most profoundly, and I think that has a lot to say about checking and cross-checking these things. And now, in the case of Peter Peregrine, he did some studies from the data files on past civilizations and came up with 37 cultures in this first millennium AD time period, especially related to the 536 crisis, or to the 6th century crisis, and and found what amounts to in this verbiage 37 mouse models of what's gone on in the past. I think that probably a good part of the recommendation of this, which is, if you're like me, let me see if I can move my I don't know, you can move the picture of the people in this thing over to the other side if you like. You can see this graph, and if you look here in the first millennium AD, well, you see that there's kind of a plateau in the development of empires and dynasties, these agrarian empires that have an element of marine transportation built into them. And that kind of divides history up to a pre-first millennium AD period in which urbanization is basically developing between about 5000 BC and 0 AD, and then you have this plateau where things are kind of stable for a while, and then you get a big buildup again in the second millennium, and this is the beginning of world empire. It's really the beginning of our current world economic system, although not in the form that it's taken since World War II. And so it's exciting. So there's a peculiar kind of, usually we think of the first millennium CE as being very unstable and tragic and everything, but really it's kind of has a peculiar kind of stability salted in with instabilities at every 300 years. The third, sixth, and ninth millennium crises, as they call them in history, and these are worldwide events which give us a lot of comparison between what the crises are, how crises are impacting the civilizations of those times, and then we have a lot of kind of revisionist history things going on now that I think are of special importance in regarding our own time. Is we have what this author Emmerbar calls a pointillist empire, which is constructed out of a 1946 document that was passed around among the Allies at the end of World War II, and set up a consular sort of government. Sounds sort of like that where we are headed toward, or at least involved in some kind of a consular system, but it's been maintained in large part by the U.S. military power, and has resulted in a lot of unintended consequences, like huge amounts of economic disparity and like Christian was mentioned, these things are, if you look at both sides of the Atlantic, while you have an added dimension to this business of the first millennium AD, having a lot of independent tests of different kinds of mouse models, which, because the subtropical high that develops over the North Atlantic is influenced by the global average temperatures. So it's kind of an index, where that tie sits is kind of an index of global average temperatures. And in a cold world, it retreats kind of in toward the equator and virtually disappears. And in a hot world, it expands up over the far North Atlantic, and where it warms these whole areas, gives France a nice warm, dry summers for wheat to mature in and things like that. And that gives you manifestations like the high Middle Ages. And when it cools down, you get drought all the way virtually to the Pacific. So, and that's driving those sorts of developments on both sides of the Atlantic. So it offers you a lot of comparison among these first millennium AD hegemonies. Something that we clearly need to keep in mind while we're developing a vocabulary for talking about first millennium CE conditions is that the Earth's ecosystem isn't just a matter of our own planet, but it has other components to it that are astronomical, like variations in the output of the sun itself, variations in how that heat is distributed over the years and things like that. And then we also have another component which becomes powerful basically after the Bronze Age, and that's an increased production of methane from human activities, and so this comes out of the work of an oceanographer, and so he sees things in a pretty broad range of things, and he incorporates the natural sea. This is the Milankovitch precessional cycle coming in here like this, and so you see it peaks in the Holocene, and then descends on down to about our present day, which would like to put us back into another ice age. The astronomical Earth system sees the situation of the world as basically one in which the world should be back in another ice age, but it hadn't gone that way. And you can see that since the Bronze Age, well, there's been an increase in this greenhouse gas called or the methane greenhouse gas, and it has its ups and downs, to be sure, which we'll get into more in the next slide. But basically, the trend is upwards, and before the Bronze Age, the methane in the atmosphere just followed the precessional cycle, but afterwards it's departed from that and gone on an upward trend. And if you look at other indicators, such as the North Atlantic sea level, we can see that there's a lot of variation in the sea level that kind of roughly follows the ups and downs in the methane. And so here you have what I was talking about in the previous slide. You have the way that the Earth astronomical system wants to go, return to another ice age, and then superimposed on that, you have this basically anthropogenic warming system. But the way I see the pre-industrial age is kind of like a 5,000-year battle between or 4,000-year battle between humans to gain control of the Earth system and the astronomical Earth system wanting to hang on to those. And usually when you see these returns to the astro-Earth system levels, as in those are caused by major events like mostly huge volcanoes in the pre-industrial age. But after about 1600s and beginning of the use of fossil fuels, humans basically grab a hold of this, and it takes now a very large kind of disruption of some sort, at the level of super volcanoes and nuclear war and those kinds of major disruptions, to bring about some kind of a one of these dip backs toward the natural course that the system wants to take. Now, tracing the way that the system has actually gone using the oxygen-18 isotopes from Kilimanjaro. I like the Kilimanjaro ice core readings on oxygen-18, because oxygen-18 gives, as you know, relationship between the ice in the global system and the water in the global system. And so it measures basically sea level rise and fall and how much ice there is in the world. And what I like to, if you focus in on this first millennium AD, you see what about the first half of the first millennium is an episode of global warming, certainly ups and downs, and the second half is about an episode of global cooling, which terminates with the 9th century crisis, and so this is kind of equivalent in a way to our own situation, where we've had global warming, not a 500-year period of global warming like this in the first millennium, but one that's driven by the much faster rise in greenhouse gases over the last couple of centuries. And then that's followed by an episode of global cooling, which might be something, caused in our current situation by a super volcano explosion or an encounter with an asteroid, or something more bound to the ground like a pandemic, which we all have seen some of the effects of, and you need to still keep in mind, even if you start counting the industrial age from something like the 1600s or something like that, you need to keep in mind that humans are not totally in charge yet. And there could very well be something like the Little Ice Age, which sits right in here, where there was a drop in global average temperatures, apparently because the population of the Americas largely died off in the face of Eurasian and African diseases. So one of the things that this is basically looking at the this is the warming trends, and so now let's go to this concept of the future past, and kind of do a little. This is getting to the question of what kind of vocabulary goes along with this future past construct. And I want to basically just want to point out that there's a range of livability, not just convenience. Like you can think of the range of Holocene temperatures, global temperatures, but there are also existential ranges. Like I've done some informal research on how hot humans can take the conditions, and the hottest place in the world, especially right now, is in the east, along the east side of the Arabian Peninsula. And I have the good fortune of having a brother-in-law who spent a lot of time working along that eastern shore of the Arabian Peninsula, and he was setting up microwave systems along there, and he was telling me that also I have another informant who's worked along there in another capacity, and they're telling me that the people can live in that area in conditions that are kind of like up to 150 degrees or something like that. It's not the best life. Like they live in caves, and it's sort of reminds me of Dune in a way that the conditions are very marginal for human beings, certainly as we understand them. Then at the other end of the global average temperature spectrum, which would be, probably 6 degrees or 5 degrees cooler than it is now, you have the ice ages, particularly the last ice age, which was the most radical of them all. But what's notable about that was that even with the great abundance of life in the low latitude tundras of the ice age, I saw an estimate somewhere that the world only has about 10% of the carrying capacity that it would, under the warmer, wetter Holocene conditions. And basically, under those conditions, the whole world is a cold desert. And in a way, life probably moves to the sea, because that cold desert yields up a lot of iron-rich dust, which goes into the ocean and probably makes the oceans more the center of life and activity than the Earth's surface. So what this suggests then is that there's a curvilinear function that describes the billion, how Earth is going to have, exercise its carrying capacity on humans. The biophysical economists subscribe to the idea that there's a limit to growth, and so we're looking, and they basically think that the Earth is now at probably about 150% of what its real carrying capacity is. They don't expect the population of the world to go much above 8 billion, and with the petroleum thing figured into it, where there's a good chance that there'll be a major reduction in human populations in the not very distant future, and so this is probably like the 20th century, early 21st century sort of carrying capacity of the Earth, and it's going to be a downhill trip either way that you go from that. Which, interestingly enough, I've seen kind of people struggling with the possibility of engineering the world's climate here and there in the last few years, and I think that we can't really expect that we won't have to engineer the world's climate, because we've already been at it for 4,000 years, 3,000 years probably, and we just can't suddenly cast off the controls that humans exercise over these world climates now. So I don't know, it looks to me like unless we want to drop back to about 1 billion people in the world at the most, we'll probably need to contemplate something like that. And what we've been finding out in the Maya lowlands is that there seems to be some kind of an attractor system that sucked the Maya classic cities into a system, a Mesoamerican wide system, and of commerce, and that attractor kind of like why did the Mesoamerican, or why did the lowland Maya build these cities on hills that were dependent on a certain amount of rainfall every year, and to restore their reservoirs? And I would think that probably they were in competition with the other cities like Teotihuacan and Kaminalhuyu and and other places around Mesoamerica that in order to do that, they needed to make large information exchanging cities. And so they were driven to making these cities on hills with reservoirs and dependence on annual rains for maintaining public health, and that commerce went on for some time. Now, in their case, they eventually ran into the severe droughts of the 9th century, which caused them to change their business system model from one of transpeninsular traffic to maritime traffic along the coast. And so the Maya didn't disappear; they just changed their location of their core cities. But what the 9th century drought business did is acted as what you could call an attractor extractor, I guess, which is like the interior cities of the Maya were basically moribund a century or two before they actually collapsed. They were just kind of running on vested interests, probably we would think of them now. But when they ran into this global catastrophe, globally generated catastrophe of terrific droughts at the end of the classic period of the Maya, well then that was sufficient to not only collapse the Maya lowlands, but the whole Mesoamerican system. So it's kind of like that the other elements of the Mesoamerican system were propping up the vested interests in the interior cities of the Maya lowlands. But then when not only the interior cities, but also the whole system collapsed, then that caused this gigantic transformation from terrestrially oriented to maritime oriented commerce. And following that, they did a pretty good job of setting up a sustainable culture. And so that's one example that shows that what happens if there are collapses and people learn their lessons about sustainability and apply themselves. This is basically a graph of that, and it shows that probably the Maya lowlands at what appear to be their peak, a period of interior city-based commerce went through a series of cascading effects, which ended with the drought stuff in the 900s, starting as early as the 800s and a little earlier than that possibly. But what they did was they separate, eventually that system collapsed and the maritime coastal cities took over. So getting off to a little piece of a new vocabulary is kind of interesting. I suppose that you've noticed that this seems to be headed toward a bunch of small species metaphors, with canaries, the coastal cities being canaries in the urban works, and mouse models for getting some ideas about what decisions were made and what unintended consequences were not avoided and the like. But I was doing a little bit of research on canaries. This is kind of maybe a troublesome metaphor because I'm not certain how widespread in the world the idea of canaries is, canaries in the cave mine, but in cultures where they have coal mines, they take a canary with them, and I've always pictured it as, the canary in a cage, and when the canary croaked, well, then everybody knew they needed to get out of the mine. But I found this very interesting device that they used, which seems to be an air-sealed chamber, and they're carrying it along, and the door is open, and the bad air, methane, interestingly enough, is coming in, and they keep an eye on this canary, but they don't let the canary die. When they see that the canary is getting woozy, they slam the door. This is obviously some kind of an air bottle, and they pump it back in there. And so going totally wild with the parallel between canaries and mines and the current world situation, we're already in a situation, where the canary is in here and it's getting woozy, and we need to be thinking about what we're going to do, but we don't want the canary to die, so we need to close the door and get some fresh air blowing in there and keep that poor canary alive for our own benefits. So what do you think of that, Vern?
I like it. It's a great metaphor.
Small species.
No, nice job. Really interesting from my vantage point. Are you wrapping up now, Joel? Is that it, or where are we?
Yeah, that's the end of my part of it.
Okay, thank you so much, Joel. Let's open up for questions or comments. Vern, you had some thought there?
I want to see you all. I'm trying to just get this back into shape. First of all, I found it really intriguing, Joel. You cover a tremendous amount of information. And from my vantage point, not necessarily very uplifting. Not that, that isn't the way it is, but a couple things. One thing is you talked a little bit, well, this whole business about the oceans maybe being in some degree a salvation, and not just the trading implications, being able to use maritime exchange and all that in a different way, even with high sea levels, which will relocate a lot of those coastal cities. But you mentioned that if we go into real droughts, the sedimentation rates may elevate and affect the abundance of food sources, algae and the like, for fish and marine products. And would you say that is our future? I mean, that is the oceans themselves, although they're being affected clearly, by acidification and the like. But within that context, our oceans are way out of this puzzle, I guess.
Well, I don't know, comparison to the Pleistocene oceans, where they're being enriched by the droughts. The globally warm oceans are actually, there's a phenomenon that might work with that, which is that you've probably been seeing about sky rivers recently, and that seems to be what one of the kind of unexpected things that's happening with global warming is that you get these sky rivers under jet streams, that there's just huge amounts of rain, to the devastation of everything on it. And then on either side of the Sky River, you get devastating droughts because the Sky Rivers stabilize in the warmer atmosphere, and so there might be some dust from those sorts of situations that enrich the oceans and and make them more serviceable. And I think the main thing that we have to do is we just have to stop the greenhouse gas production. If we don't stop the greenhouse gas production, well, then we're facing the end of our species and all, other, not all species, but certainly most of them.
Mhm, mhm.
Thanks.
But it's nice to think about that. What was that movie a few years ago where one of the famous actors is making his way across the life of the ocean and
Yes, the water worlds or something. I remember that.
water
Dystopian.
world, I think.
Yeah,
Yeah, that one.
Yeah. So get your boats out, guys.
Okay, thank you. Anyone else?
I have another one if no one is going to raise their hand.
Go ahead.
Joel, you mentioned that in the New World, just after the reconquest or whatever the proper terminology is now by the Western empires, and smallpox and related diseases wiping out maybe 90%, 80% of the indigenous population. That one thing that it's being kicked around now is that what happened in part with global climate change was that the landscape prior to that time just had fewer trees because people were densely occupying that zone with irrigation and reservoirs and relatively complicated ways of changing the landscape and removing a lot of the carbon sinks that would have been available via great tropical forests. But as soon as that happened, trees began to really fluoresce and you had those carbon sinks back in place. So that may have affected temperatures globally, that kind of thing. Do you adhere to that thought? Is that something that was happening to change climate as a result of depopulation, in essence, of the New World?
Yeah, there's a paper out on it that suggests that was the reason for one of the contributing factors to the little ice age. Is probably a combination of low solar emissions and the decrease of carbon dioxide in the atmosphere, because those the Western Hemisphere included a lot of methane producing agriculture, like the Eastern Hemisphere did. And so the outcome of that was a reduction in global average temperatures. It was very noticeable.
And in that same vein, that same thought, do you think the move globally, even in the Sahara, and other desert settings, is plant a bunch of trees? Is that really going to make much difference, particularly given that those trees require water, to sustain that vegetation, given drought-like conditions globally?
Yeah, there's plenty of water in the atmosphere over the Sahara Desert. Is just the surface is so hot that it will, even if it starts to rain, it will not reach the ground, except in the mountainous region like the Debesti. But and that I saw a plan, and it's reappeared in the literature somewhere in the last few years for converting the Sahara Desert into a giant carbon sink, like you were mentioning. And so So, and also, like I mentioned at the beginning, a lot of the greenhouse gas effects are already baked into the system, and who knows how far out they reach. And so there needs to be a lot of carbon sink activity going on, just to head off the problems that we've already gotten ourselves into, much less the ones that we're likely to create if we continue on the track that we're on.
Thank you.
Anneli.
And but I've been seeing a lot about how the salvation of the greenhouse gas world is kind of more with grasses than it is with trees. That grasses can sink a whole lot of carbon in the soil, and that's particularly the case in Argentina for some reason, I suppose because of the species of grass that they have that runs roots about 30 feet down into the ground, so that kind of grass is able to sink a whole lot of carbon into the soil.
Yeah, so I will continue with Ron's discussion, but because I'm working with vegetation history in Southern Africa, so I always feel provoked about this, the Saharan green wall, as it is called. So actually, when we look at the aerial photographs from the 20th century and 21st, is actually the savannas who are contracting. And Bond et al. Have argued that it's because of fertilization from carbon in the atmosphere that encourages tree growth. So, and it now gets me to my question to Joel. So there has been several authors that have in some ways criticized how science presents the dilemma of the Anthropocene. And one of the most explicit in that criticism is maybe Donna Haraway. And I think she's right. She says that when we talk about Anthropocene, we make it out as either, a Edenic or awful past, or a, awful or salvic future. But the point is that discussions, whether it's about the past or about the future, obstructs us from thinking about the now, like now when we need to truly act. And I was very happy, Joel, when you started your talk about time, the discussion about time. So can we, my question is, like, how do you see the now, the actuality of the now and what we need to do, not geoengineering in the future, but in this very moment? Yeah.
I see what you mean. My main or biophysical economist colleague in all of this is reports that he's driven by the concern for his grandchildren, and that now is the moment that we have to deal with what kind of a mess we're in. And there's just no escaping it. Who's the guy from Yale that did the hockey stick stuff?
But can I take just an example? Like, so sometimes I feel we're going, we're doing the least easy ways to solve this. So we could restore our wetlands, for instance, and they would bind a lot of carbon. It's a very easy thing to do compared to planting the whole of Sahara green. That's like
Oh,
any
yeah.
possible
Yeah,
protest.
I'm
But it
certain
feels
you're-
like
you're
some of
right
these,
there.
yeah. Sorry, that was more like a comment than a question.
Well, certainly something we need. I read a book recently, The New Climate Wars. I can't remember right now who the author is. He's the guy who invented the hockey stick idea and has taken all this grief from the oil companies about his hockey stick ideas. And he's written this very sane book about how the you know, how much deception there is going on in the news media. He calls it deflection, and all the fossil fuel industry is doing and has done for some time is deflect our attention from the now. You put your thumb right on the button there. That's what they're doing, is deflecting our concerns away from the immediate present, so they can keep on making their $2.8 billion a year off of digging up fossil fuels that need to be left in the ground. And that's, and we need to take, the most obvious and easy ways, wetlands and grasslands and stuff, and get them going. And I see occasional reports, of nations in Africa taking this on while the United States fumbles around and doesn't do anything about it. Actually, that's not true either, because even though the federal government has come under a lot of control from the fossil fuel industry, cities and states in the country are proceeding with joining the understanding that, yes, we have to do something about it. And the question is now, and talking about vocabulary and durability and things like that, maybe we need to have a slightly revised vocabulary that allows us to speak impactfully about what, the reality of the present and the just, the kind of fleeting disparity of the past and the future, and be about what, what the apparent easy stuff is quickly. Although Michael, whatever his name is, he says that, I know if he is right, why I've been somewhat profligate in doing what he calls global warming panic or something like that. He has a term for it. That book might, the New Climate Wars might be a source of looking for vocabulary to do the right speaking about these matters.
Thank you. Anyone else? If not, it's fairly late in the afternoon in Sweden, and I suggest that we wrap it up. And thank you so much, Joel, for your thought-provoking presentation.
Well, thank you for the opportunity to practice on somebody and get some response.
We were the
Yes.
canaries. All right, so thanks, Joel, and thanks all. We'll see each other within the seminar series again in about 2 months.
Yes, and in 1 month is the AFRES seminar.
Right, the African
Yes.
parallel seminar series. Thank you. Good night.
Thank you.
Thank you.
Thank you.